Good evening, everybody, and welcome to Slooh. We're going to learn to explore space, and I don't know about you, but I'm getting pretty excited about the subject of this particular live cast. We are now on our countdown to the, we've got 2 weeks to go until our Slooh Members 2018 Messier Marathon. Now then, you guys know the deal by now. I need to just hop over to the Situation Room. And by the way, if you are hearing this strange English voice over the airwaves, if you're browsing around Slooh's website, then hop over to the Space Situation Room by going to Livecast in the left-hand nav and up to Space Situation Room. You can also, if you want to carry on doing what you're doing, maybe you're booking up the telescopes for Chile later on. I know there's some spare slots there, but if you want to be antisocial, not interested in the viewing event of the entire year, then you can just hop up to this little our little audio player up here, and you can mute my sound up here. But anyway, I've just got to hop over to the Space Situation Room to make sure that you can see and hear me, and it looks like you can. Hopefully we're not going to get the same kind of buffering maybe that we had last week. But what are we here for? Well, it is, as I say, I'm just going to make one more check. Yeah, that's good. We are here to prepare for the Slooh Members 2018 Messier Marathon. Now, if you haven't been around over the last couple of weeks, here's a quick recap of what a Messier Marathon is. Now, in fact, let's hop over to telescopes and scheduled telescopes, and we'll go by catalogs. And what you can see here is a list of the most commonly used astronomical catalogs. Each one of these contains objects which are sometimes geographically located in the sky in the same kind of place, but most of these catalogs are limited to one type of astronomical object. So you can see here one of the largest catalogs we've got here is the Tycho II catalog. It's a fairly new catalog of 2.5 million stars. We've got the Uppsala General Catalogue of Galaxies, one here for nebulae, reflection nebulae. We're going to talk about that a bit later. And then hopping up here, Galactic Planetary Nebulae, Principal Galaxies Catalogue, the PGC. The big one, the new General Catalogue of Nebulae and Clusters of Stars. We're doing a lot of work on that at the moment, actually. But here's the one that we're interested in. The Messier Catalog of Bright Extended Objects. And as you can see here, we say the format that you want to enter in here is 1 to 110. So if you want to do one of these, you could pop in here. Let's go M31, check visibility. And don't let me down now. There you go. Cannot be imaged at this time. All right, let's go for another one. Let's go for M45, Pleiades star cluster. Yes, it is. Open star cluster, I think we'll go for. Or in fact, you know, we want the nebulosity in this. I'm going to talk a little bit more about this later on. Faint nebula, schedule mission. Anyway, so listen, the point I was making there is that there are loads of catalogues. And the one really that we're interested in for our Messier Marathon is, of course, the Messier Catalog. So what is it? Well, it's a catalogue of 110 of the biggest, brightest, most spectacular objects in the night sky. But that's not why the author of this catalogue, Charles Messier, it's not why he created it in the late 1700s and early 1800s. He was one of those, oh my word, if I ever wanted to travel in time, I'd be going back to the Enlightenment. I'd be going back to the maybe 17th and 18th centuries, where all of our gentlemen philosophers, these early scientists, were developing the scientific method, and it was an age of discovery. And Charles Messier, this French astronomer, was a discoverer, not necessarily of all of these 110 objects that he later put in his catalogue, because a lot of those objects, including the very first one, Messier 1, or we normally leave off the Messier, we just call it M1, the Crab Nebula, that had been discovered 20 years before Charles Messier put it in his catalogue. No, what Charles Messier was trying to discover were comets. These objects that come into the inner solar system every now and again, and sometimes can be absolutely spectacular, like actually the very first comet that Charles Messier hunted for. It had been predicted. It was the first comet to be predicted. It was Halley's comet. And Edmund Halley, Astronomer Royal in London, in Greenwich, the Greenwich Observatory, he had predicted this comet would return, because what he did was he looked through hundreds of years of observations of comets from Chinese, even I think Arabic astronomers, hundreds of years in the past, and he identified this one comet that seemed to be observed on a regular basis, just over 70 years or something like that. And he then predicted its return. And unfortunately, poor old Edmund Halley didn't actually live to see the return of his comet. But Charles Messier did observe it. But unfortunately, the person who he reported it to didn't publicize that Charles Messier had observed it. And in fact, it was something that Charles Messier really looked back on with disdain over his entire career. He did say, I think, that it was his one regret that his observation hadn't been noted, because when Halley's Comet did return, Messier was saying, well, I observed this 10 weeks ago. But of course, everybody else was quite skeptical. Why didn't you tell us back then? Even though he had submitted this observation. And, you know, we talk about it actually at Slooh quite often, when members think they may have discovered something. Discovering something, spotting it in an image, isn't good enough. You have to report it, and you have to be the first person to report it. So anyway, Charles Messier was hunting for comets. Doesn't matter what kind of comets, he wanted any comet, whether they were long period comets or short period comets. Short period comets are those that are kind of caught up in the solar system, in the inner parts of the solar system, can go out to about Jupiter, even slightly beyond, out to Uranus and Neptune, I think. But in their periods, they return around the sun for their perihelion, which is when they're closest to the sun, less than 200-year intervals. Then you have long period comets, some of which only ever make one visit to the inner solar system, and they can be pretty spectacular before they whiz out and we never see them again. But you know, some long period comets do actually return, so it's not like it's just periodic comets and normal comets. Both can actually be returning. It's just the period of time. Anyway, Messier didn't really care what type of comet. You know, he was hooked. He was a comet hunter. And over his career, he discovered and co-discovered over 20 comets, which is some going. You know, it would be pretty difficult to do that now because of what are called these all-sky surveys. These are professional surveys of, you guessed it, almost the entire sky. And some of these surveys cover the entire sky in a single night, looking for what are called transient objects. And a transient object might be an asteroid, it might be a comet, it might be a nova or supernova in another galaxy. So there goes my alarm saying, excuse me, but Chile is should be opening up fairly soon. Sorry about that. God, being disturbed like that. Anyway, there we go. So Charles Messier, why on earth was he putting these 110 objects in this catalogue if what he was actually interested in were comets? Well, the problem is he kept peering at these objects and confusing them with his prey, his quarry, comets. So what he decided to do was put all of these other objects, like this one, in fact. Look, on the homepage, who shared this one? Oh, this was Nicole B. Thank you, Nicole. Great example here. The Lagoon Nebulae, M8, which means Messier 8. It was the 8th object that Messier put in his catalogue. And all of the objects that he was putting in through his early telescope kind of looked diffuse and looked a little bit like comets. They could easily be confused with comets. So that's why he put them in this catalogue, because when he was pointing his telescope to a certain region in the sky, he saw something small and fuzzy, potentially a new comet discovery. All he had to do was flick through his catalogue pages, look at where he was pointing at the time to see if he had catalogued an object in that particular location. So that's all. It's the only reason why he was generating his catalogue. Now, shortly after he published his catalogue, the Messier Catalog, one of my other heroes in astronomy, Sir William Herschel, published what would become the new general catalogue with nearly 8,000 objects in it. He didn't add all of those, but he, his sister Caroline, his son John Herschel, and a chap called Dreyer also added to that catalogue. And Messier didn't, after the general catalogue was published by Sir William Herschel, who was William Herschel at that time, got his knighthood a little bit later, he didn't really have any need to either update his catalogue or produce and publish another one, because William Herschel's catalogue had captured so many more objects, but still it was Messier's catalogue which was most helpful to comet hunters, because most of their telescopes were not as good as William Herschel's telescopes, and of course he used a number of very, very large telescopes as well. So a lot of people through their own telescope. In fact, even now, if you buy a kind of sub $500 or maybe even sub $1,000 telescope, you know, you're only going to see the brightest Messier objects as a faint fuzzy patch, probably without any color whatsoever. But anyway, so that's why this catalogue came along. But why and what then is a Messier Marathon? Well, a Messier Marathon, it kind of started off in the amateur astronomy world in the age of visual observers. By visual observer, I mean people who were looking through an eyepiece through their telescope. And they had to develop a huge amount of skill. They had no computer running that telescope, pointing it exactly where they wanted it to. No, they had to learn something called star hopping. Now, if you look, actually, let's take a look and see what we're talking about here. Let's take a look at the Sky Planetarium software. Here we go. Take a look at this. So here's the Sky Planetarium software. And let's just switch on some labels. Let's have the Messier object labels coming on. So what they had to do was look at all of these constellation figures here. So let's just look east maybe. And here we've got the constellation of Virgo here showing up. If an amateur astronomer wanted to observe, let's say M61 here, what they'd do is they'd point their telescope to the brightest nearby star, maybe this one down here, Porrima. Gosh, I've never heard of that star before, in the constellation of Virgo. And then they'd move their telescope up in the direction where they knew another bright star was. So they'd come up to this one, Xania, another really cool looking star. And then what they'd be doing is they would know, they'd have a star chart which located the object that they were looking for, M61, in relation to other bright stars. So they might then start honing in. And let's just zoom out a little bit on this. Let's go north up, just twist that around a bit, zoom out a bit more maybe. So all of the bright stars that they'd be seeing here, there's that star that we were talking about here, they'd be looking through their eyepiece and they might then star hop to other brighter stars. And here's one very bright star here. So there you go. What's that? Magnitude 5. You can actually see that under a dark sky with your own vision. But what they do is they'd star hop to that, which is an unmistakable star, and then they'd know, well, M61 is just a little way up here. So that particular spiral galaxy, M61, they'd know that the next fuzzy spot they came to, that would be it. So anyway, that's what star hopping did. But Messier Marathons are still great fun in this day and age of not only go-to telescopes, computer-controlled telescopes, but also telescopes like Slooh's, robotic telescopes. And let's just have a look. We're going to switch on our database. Optional databases if you've got the Sky. If not, you can, whatever planetarium software you've got, you might be able to load something like this up. And I've just loaded up the Don Matscholt's Messier Marathon catalog. I'm just going to switch off Messier object names. So here we can see all of these objects, and I'm just going to stop the date. I'm going to set it to the 17th. We're going to talk about when we're doing this a little bit later. And this is the start of missions on that night, 2010 UTC. So what happens around mid-March to early April? By the way, what those guys were doing, those visual observers were doing, was they were trying to observe every single one of the 110 Messier objects in a single night. And that's what we're going to be doing on March 17th. But why March 17th? Well, there is this period of time every year which is really well suited to Messier marathons. In fact, it's the only time, from Earth at least, you would be able to observe every single Messier object in the hours of darkness. And this period runs from approximately mid-March through to early April. So you might be asking, why has Slooh decided to choose the 17th of March as our members' Messier Marathon? Well, I'm going to spark up another piece of software here. And this is a piece of software called Quick Phase Pro, and it tells you just about everything there is to know about the moon. And it's got a nice little month view here. And here we are looking at March 2018. And what we see here on the 17th is two little letters, NM, meaning new moon. Now, a lot of Messier's objects, although they're bright, they can be badly affected by moonlight, whether or not you're observing them visually or with a CCD camera. If there's a lot of moonlight out at the same time that you're trying to observe or take images of them, then it really spoils those images, and it makes it virtually impossible actually to be able to spot some of these objects, these faint objects, under moonlight visually if you're looking through a telescope. So there you can see, so this is not, we haven't actually just picked it because it's new moon. The new moon just happens to be coincidentally on the 17th. But what we've really done is we've picked the Saturday in mid-March to early April, the Saturday that has less moonlight than any other. Saturday, why? Well, that's because most of us have to be up early, working during the week. So if we did it on any other day of the week, Friday, I guess we could do it Friday, but you've had a long day then at work. Can you really stay up all night to do a Messier marathon? Probably not, you know. So there it is. That's why we've chosen March 17th, because it's a Saturday night, because it has very little moonlight, and it's within the period of time where we can observe all. In fact, you couldn't see any of what I was talking about then. What a shame. There you go. This is Quick Phase Pro. Sorry, you still can't see it. I need to press another button for it to come up on your screen. There you go. There's Quick Phase Pro. There's actually what I was talking about. So if you look at this on the 17th over here, this is when we're going to do our Messier Marathon. And there you can see it's in the middle of this kind of period and new moon. And it's Saturday night. So sorry about that. Let's go back though to our star chart. There we go. Just going to turn another thing off. And this is actually what we're using. And instead of seeing all of the objects labeled Messier 1, 2, 3, 4, all the way up to 110, what this particular database does is it tells us the target number. So what we could do up here in the sky, we could actually search for target 1. And where is it? Did you see it? Yep, there it is highlighted. Let's look east. So don't forget, I've set this sky chart to be on the night of the 17th March, Saturday night at 2010 UTC, and that's when the telescopes start operating in the Canary Islands. So what this database does is it's ordered objects in roughly order of setting, certainly this first group of objects. And this is what we've got to be really, really clever and smart about, because as each minute goes by, objects in the east are setting. So I'm just moving our star chart forward 1 minute at a time, and you can see all of these Messier objects, 1 to kind of 10 around that region, are setting quite fast. So if we whiz forward even more, look, we know already that target 2 now, what's target 2 elevation? It's telling us over here, it's 10 degrees above the horizon. Now that's actually behind the bushes in the Canary Islands. So we know that we've got to be capturing all of these objects at least when they're above 15 degrees, which is here, which is showing us already that we've only got about 15 minutes to capture how many objects here? 1, 2, 3, 4, 5, 6, 7, maybe 8 or 9 objects within the first 15 minutes before they set. Now, unfortunately, they're not going to be the best images. We always tell members, capture your images when they're high above the horizon, when your target's high above the horizon. But we've got no choice here. These objects are low to the west. So if I said east earlier, I'm sorry. They're low to the west horizon as darkness falls. So we've got no option. There is no better time to be observing these particular objects. So if we go back to our entire sky, we can see. In fact, let's set that back to the start of when the telescope's open, and let's hop forward now an hour at a time. So you can see the right of this chart is west, so objects are setting in the west, and equally we've got a large group of objects there, all those targets there around 51, 49, kind of 50s, late 40s and early 50s. A whole mass of targets there between Virgo and Leo, which are rising in the east. So let's hop forward an hour. So bang, we know we've got to capture all of those objects over to the right because they're setting behind the western horizon. But bang, here we've got this other cluster. So we can see here that around, about 3 hours after we've started, we've had quite a leisurely pace, because after that first rush, there's quite a few objects, but fairly well spread out, including those lovely targets that we've got in Orion. Of course, we've got the Orion Nebulae, and then we're going to talk a little bit actually about some of the object types that we can see. But then we're going to have to box really clever from around 2300 UTC, because we've got this major cluster of objects. And what we want to do here is make sure that we match each particular object to the best telescope system for that particular object. And when we say that normally comes down to the apparent size of an object. So let's say M57, Messier 57, the Ring Nebulae. That's really quite a small object. It has a small apparent size, not its real size, but its apparent size, the size that it appears in the telescopes. So for that, we probably want one of our wide field telescopes, or maybe even the Canary 4 solar system telescope. What we wouldn't want to use for the Ring Nebulae is one of the ultra wide field telescopes, or maybe the Canary 3 deep sky telescope, which has a huge field of view. But in fact, let's have a quick look at a couple of examples here. Let's go M51, and I'm going to frame M51. We'll zoom out on this, and I'm going to turn it up. Don't forget, all of Slooh's images as presented to you are presented north up, and east is left. But I'm going to add on a few more field of views here of the other telescopes, so we can see exactly what we're talking about. So you won't see these until I actually get them on. I'm going to switch Chile off for now. We'll just look at the Canary Telescope. So there we go. So here we can see we've got this really quite small object right in the center of our field, the Ring Nebulae. It's a planetary nebulae. It's a sun-sized star that's kind of reached the end of its life, and it's kind of shrugging off its outer layers of material, and it kind of puffs out and forms these beautiful rings, or if we see them on the side, they look like hourglasses, like the Bug Nebulae. But anyway, you can see here that, let's zoom out a bit more. So there we go. we've got all of our Canary Islands telescopes in here. So the smallest rectangle in the middle, that's the field of view of the Canary 4 Solar System telescope. So that's the telescope that we'd really want to try and use for these small targets. You can see the next telescopes out, a Canary 1 half meter, Canary 2 wide field telescope, the two squares in the middle. You know, they're okay for using for the Ring Nebulae, but the Ring Nebula, it looks really quite small in their field of use. But then go out a step further, and then we've got the next rectangle out is the Canary 2 ultra wide field telescope. So that's the little telescope which is sitting on top of the Canary 2 wide field telescope. So whatever the Canary 2 wide field telescope is looking at, the Canary 2 ultra wide field telescope is looking at as well. And you can see there that frankly the Ring Nebula is going to be so small in that field of view, it's really going to look probably like a single bright star. So we wouldn't want to use those telescopes. But let's have a look then at another Messier object, M31, the Andromeda Galaxy. So look at this one, and you could not have a starker contrast in object size between the Ring Nebula and this, an entire galaxy, one of our closest nebulae. In fact, it's, sorry, one of our closest neighboring galaxies. It is the closest, biggest if you look at size. In fact, it's even bigger than our own Milky Way galaxy. But look at this. We can't use the Canary 4. Look, if we zoomed in and we use the Canary 4 Solar System telescope, look, we're just actually going to see the very core of M31, the Andromeda Galaxy. No good to us whatsoever. You probably wouldn't even discern its spiral arms because you're not seeing enough of it. But look here, the Canary 1 half meter telescope and Canary 2 wide field. These are great telescopes for a faint object like the Andromeda Galaxy, but they only show a tiny fraction of it. In fact, even our largest field of view cameras here, the Canary 2 ultra wide field and the Canary 3 deep sky astrograph telescope, which have fields of view over 1.5 degrees, even they don't capture the entire Andromeda Galaxy in their field of view. So anyway, this is why we're going to be boxing a little bit clever when we schedule the telescopes, so that we're making sure that we're using the best telescope for the best object. And as I say, that usually means an object size, but it can sometimes come down to an object's brightness as well. And when it comes to brightness, you want to use either the Canary 2 wide field telescope or the Canary 1 half meter telescope. Those are the two largest Slooh telescopes. And largest, we mean the biggest mirrors inside them. And the bigger mirror means it can collect more photons, which means that during a 5 or 10 minute mission, we're collecting as many photons that have been released from those far off distant objects as we can on our scientific grade CCD cameras. So anyway, let's just flick forward. So there we are. We're past midnight now. Now, I'm certainly going to be staying up all night for this. And when I say all night, I mean all night for the Canary Islands. I'm not going to stay up because we are going to be using Chile as well for the Messier Marathon, don't forget. And in fact, this shows us the reason why we want to use the Chile telescopes as well. So here we are. We're in a couple of hours now before dawn. In fact, let's just take a quick look. Forgotten what time the end of missions is on the 17th. Just having a quick look at this, having a look at our schedule. So darkness ends at 05:51 and missions end at 06:15. So let's hop over actually to 06:15. So this is when the telescopes in the Canary Islands normally stop. And look at this one down here to the bottom left, target 110. It is so low. I mean, look, it's only 3 degrees above the horizon. So what we need to do here for this object is we'd either need to use the Canary 3 or Canary 4 telescopes, which can actually look down that low as long as we've got no cloud on the eastern horizon. We know it's not going to be a great image, but that's the challenge of a Messier mount. The other thing that we can do is we can actually control the telescopes beyond twilight, which means the images become incredibly noisy because the sky is getting so bright, especially to the east, because of course the sun's rising. So that's the first portion of the sky that's going to get a lot brighter. But we should be able to capture that. But there's an even better way for us to do that without resorting to any cheating. And look at all of these other objects as well at the end of the night. So you can see the Milky Way running through here, through Cassiopeia, through Cygnus, one of my favorite constellations, and coming on through to Sagittarius and Scorpius. So the heart of the Milky Way, if I zoom out a little bit more, there you can see the actual heart of the Milky Way. The heart of the Milky Way is actually marked by the asterism of the teapot in the constellation of Sagittarius. So just off its spout is the very center. It's where the supermassive black hole lurks at the very heart of our Milky Way. But all of those objects that we saw, they're quite a long way south. For Messier, Messier was a Northern Hemisphere observer, and these kind of were the lowest objects that he could see. So let's take a look why those objects are going to be better. So look at Scorpius. Sagittarius is in the heart of all of this. You can see Mars is down there as well. Let's change our location in the sky software to be looking at the Chile Observatory. So this is now showing us the sky from the Chile Observatory. Now let's just take a quick hop over because I want to just check the time. I think it's around 9 UTC. The last mission at Chile is 0945. So let's put our clock to 0945. So this is what the sky above Chile is going to look like at the end of missions on the night of the 17th. So this is the morning of the 18th. Look at this target 110 down here. Down here it's 25 degrees above the horizon because it's not skirting the southern horizon like it did from the Canary Islands. But look, we've got this mass of targets which were all quite southerly, lurking just above the southern horizon from the Canary Islands telescopes. But the center of the Milky Way, Sagittarius and Scorpius, go overhead in the southern hemisphere. So what I reckon we should be doing is we should be capturing some of these more southerly objects with the Chile telescopes because they're far better placed from down there, and some of them are really quite large. A lot of the nebulae down there are quite large, so they're really going to suit the telescopes of the Chile 1 ultra wide field and the wide field, but the ultra wide field will come into its own. So anyway, that is how we're going to plan it. Now, what else was I going to talk about tonight? Well, if you are new to astronomy, I've been saying over the last couple of weeks that a Messier Marathon is just such a wonderful learning exercise. They're great fun because you're going to be doing it with hundreds of other Slooh members around the globe. And hopefully some of you guys, let me know in the discussion boards, let me know if you're going to try and stay up for the entire night. I'm definitely going to, and I'll be on air from time to time, and hopefully we may even get some of you guys coming online to join me, have a quick natter about whatever we're seeing at the time. But it's a superb learning opportunity because we're seeing so many different objects of different object types in a single night, and we can compare and contrast them so easily. So it's not just about the different object types. What are we going to see? Well, the very first Messier object in his catalogue is M1 Messier 1, the Crab Nebula. This kind of stands alone as an object type. It's a Supernova Remnant. We never really know where to put these. When we list objects for you guys to make reservations, schedule your objects your reservations. We're never really sure where to put this. Should we put it under nebula? Not really. Should we put it under stars? Well, it kind of suits being under stars more than it suits being under nebula. And what this is it's not like the Ring Nebula, which is a planetary nebula, which is a sun-sized star at the end of its life, where it kind of just shrugs off its outer atmosphere, which is really quite a cosmically violent event, but it is nothing in comparison to a supernova. So this is a star over 8 times, probably a lot larger than our sun. And when a star like that ends its life, it does so in a cataclysmic way, not only for the star itself, but maybe for any planets which are in its surrounding solar system. We kind of didn't used to think this was a big issue because we kind of never thought that there were many stars with planets. But now with all of the exoplanet discoveries, we know that actually it looks like most stars have planetary systems. They have their own solar systems. So think of any planets around the star, which is now the star itself is actually, the remnants of it are right in the center. It's a pulsar. It's the remnants of a star called a pulsar, which is rapidly spinning. And I was very fortunate once to meet one of the people who first discovered pulsars, Dr. Jocelyn Bell Burnell. But anyway, a supernova remnant is what happens when one of these very large stars ends its life. It basically runs out of nuclear fuel. It's hydrogen and helium in the center. And it starts then fusing heavier and heavier elements until it gets to starting to fuse iron. But the problem is with iron, that to fuse iron, you have to put more energy in than it's giving out. And that means that what's called the radiation pressure, which kind of keeps the star, these large stars, from collapsing under their own gravity, that no longer exists. So what happens is that star does collapse under its own gravity. And when all of its outer layers impact its dense core, it explodes in a cataclysmic cosmic explosion. And it's basically the star blowing itself to bits. So all that's left after that is, in this case, we're talking about the Crab Nebula. You can actually see the little crab pulsar right in the center of it, I think. Not sure if you can see it visually, actually. Need to check that. But anyway, what we see around this supernova remnant is the star's outer shell being blasted off into space. And actually, some of these things are reflection and emission nebulae. Both they can be both. But anyway, so we're going to see a supernova remnant, the Crab Nebula. We're going to see star clusters. Now, star clusters come in two. You might stretch this to a third, but when you talk about the categorization of astronomical objects, you really talk about two classifications of star clusters, both globular star clusters, and one of the best ones we're going to see on the night is M13, the Great Hercules star cluster. That's a great one. That was discovered by Edmund Halley, the guy that I was telling you earlier about, in 1714. Now that cluster contains about 300,000 stars. But we're also going to see the M2 globular cluster. That was discovered actually nearly 50 years after M13 was discovered. And these are very, very old clusters of stars. So I think M2 is something like 13 billion years old. That's nearly the age of the universe. What is it at the moment? We think 13.75 billion years old, something like that. But anyway, the other type of star cluster are the open star clusters. So one of the first ones that we're going to see is M6, the butterfly star cluster. And actually that's named a butterfly because the stars in the open cluster kind of take on a shape of that. And these stars are really young. A lot of open clusters have very young stars in them, which have formed out of dense areas of dust and gas which coalesce and collapse. So the stars in the butterfly star cluster, they're only about 100 million years old. So that's a pretty cool one to see. But one of my favorite open star clusters of all is Messier 45, the Pleiades star clusters. And that's dominated by 7 massive blue stars, named, of course, for the 7 sisters of Greek mythology. And in fact, the Pleiades is one of the closest star clusters to Earth. And it's very easy to see, of course, with your naked eye. But in fact, there's nearly 1,000 members of that one. So what are the other types of object that we're going to see during our Messier Marathon, where we can compare and contrast not only between these different types of objects, but also between objects within those categories? Well, Emission Nebulae. And there are a bundle of Emission Nebulae that we're going to see. And just a reminder, not going to go into it in too much detail, because we're doing all of this on the night. You won't really dig into each one of these objects that we're looking at. An Emission Nebulae is a cloud of ionized gas, and it emits, as its name, it emits its own light in optical wavelengths. So what happens is an Emission Nebulae, it's usually the surrounding cloud of interstellar gas is excited by nearby, it's usually O and B type stars, which are giving off a huge amount of ultraviolet, high energy ultraviolet photons. And this breaks apart hydrogen atoms in these big clouds, and yeah, they emit light, an Emission Nebulae. Now, 2 of the great ones that we're going to see, in fact, one was on the homepage there. Nicole B had shared that. In fact, was it that one? I think it was. The Lagoon Nebulae, Messier 8. And that's a beautiful one. Yeah, that's a massive object in reality. It's still quite large in our scopes, but it's 110 light years across. And that one shines pink from the massive stars at its center, ionizing that enormous cloud of gas and dust around it. But of course, the other famous Emission Nebulae that we're going to look at is M42. Now, if there's ever a Messier number to remember, it's M42, the Orion Nebulae. And this is one, of course, that you can view with your unaided eye. You can even see with binoculars. You won't actually see very much detail, but you'll certainly see that it's a pretty cool nebula. Other types of nebula that we're going to see on the night, Reflection Nebula. Now, Reflection Nebula is more about light from a nearby star just bouncing off or scattering the light of a nearby star. So this is another cloud of dust and gas, and a nearby star isn't radiating sufficient high energy, UV or anything like that, to excite the particles of hydrogen and other gases in that dust cloud. Instead, that dust cloud just reflects the light. So that's a Reflection Nebula. And one of our favorites, of course, in the Slooh telescopes is Messier 78. Now, that's doesn't have another name, that one, I don't think. So it's just Messier 78 Reflection Nebula. And about that one. That one's only 4 light years wide. Interstellar dust that shines in the reflected light of the bright blue stars that are in that area. And it's actually in a far larger area, in a vast molecular cloud complex, which is part of the Orion Nebulae. Anyway, what else have we got? We've got one more type of nebula, and that is a planetary nebula. Now, we've already talked about that. One of the best examples that we're going to watch on the night during our Messier Marathon is Messier 57, the Ring Nebula. Now, we're seeing M57, this sun-sized star, which is at the end of its life, shrugged off its outer layers. We're seeing it from its poles. So imagine an hourglass, and the sun is in the center of the hourglass. And what happens? Well, a lot of these planetary nebulae, the way they explode, is not in 3 dimensions symmetrical. They explode like an hourglass. So instead of looking at the Ring Nebulae from the side, a bit like the Bug Nebula, which is one of my favorites in the Chile telescopes at the moment, we're actually seeing the hourglass from the top or the bottom. So we're seeing it as a circle. And that the lovely thing actually about, I think, the Ring Nebulae is the vivid colors, the blues, the greens that we see. But also we've got a whole bundle of other planetary nebulae as well. And one of those is Messier 27, the Dumbbell Nebula. Now, we were saying earlier that the Ring Nebula, M57, we want to see in one of the telescopes which gives us a small field of view, like the Canary Telescope. But we want to see, let me just check something because I think I'm rapidly running out of time here. So hold on one second. I mean, having said that, just by saying this, it kind of blows what I'm doing. Oh, you've missed me already. Anyway, listen, I'm going to carry on going because I'm going to carry on going for the recording so you can catch this still on YouTube if you're watching. So Messier 57, the Ring Nebula, we need to see that in one of the telescopes like the Canary Solar System telescope because it has a small field of view. But M27, the Dumbbell Planetary Nebula, is huge. So actually we want to see that in either the Canary 1 or Canary 2 telescopes. So that's the last of our planetary or nebula types that we're going to see that night. There's one strange little category here as well, which is Messier 24. And this one, it's not really a star cluster, but it's more a star cloud. And this is the Sagittarius star cloud. So that is going to look great in the Chile Ultra Wide Field Telescope. And then the other objects, of course, that we're going to see plenty of examples of during our Messier Marathon are galaxies. Few of our favorites. We've got Messier 31, the Andromeda Galaxy. One of my personal favorites, Messier 33. The Triangulum Galaxy. That is beautiful. Also, two of my other favorites, M63 and M64. The Sunflower Galaxy is one of the most delicate looking galaxies that you can see through the Slooh telescopes. But then in contrast, you've got this thing that looks really quite violent, the Black Eye Galaxy, with this tremendous dark patch of dust in its arms. Which kind of gives it this appearance of a black eye. But then, of course, we've got two of our favorites as well. We've got M51, the Whirlpool Galaxy. That's always a favorite. Looks great in the Canary 1 half meter and the Canary 2 wide field telescopes, just like M101, the Pinwheel Galaxy. And that one always looks great as well. So anyway, what are we going to cover next week? Well, next week, we're going to be looking at the mechanics of how we're going to get our schedule filled. So how you can contribute your missions, how you can kind of sign up to use various, let's just have a quick look at this. So let's have a quick look here. We've got our schedule here. You can't see this very well in the screen share, but we're going to go over this in detail next week. So you can go through and you'll be able to put your name to certain objects. So you can bag up your favorite objects. Oh, I might do M82, the Exploding Galaxies. That's one of my favorites as well. And we're going to go through the mechanics of when and how to do this in preparation for Saturday night, March 17th. So whatever you do, don't miss next week's preparation countdown to the Slooh Messier Marathon, because it's really going to be the one that tells us and shows us all how we're actually going to do this and get through the entire night. But anyway, that's all from me for now. I'm going to hop off and then get back online very quickly for our practical astronomy series. So all from me. Sorry if you were watching live at Slooh, if the show got cut off, but there you go, that happens. Anyway, good night from me, Paul Cox. I will see you next Sunday. What's the date next Sunday? Is the 11th, where we'll talk about the mechanics of our Messier Marathon. So goodbye from me.